The average temperature for Regina is hottest at 27 degrees Celsius on July 28th and coolest at negative 16 degrees Celsius on January 10th. We're going to draw a graph, write an equation, and estimate some things. Now, this isn't a Ferris wheel problem, so I don't get to draw a Ferris wheel, but I am going to write down that the minimum temperature is that negative 16 degrees Celsius on January 10th. The maximum is 27 degrees Celsius on July 28th. Now, my function isn't going to necessarily be exact in the sense that we're working with specific days, but it is going to give us a good representation to get some data on. So write an equation. So the couple things that I need for an equation, remember, is going to be plus or minus the amplitude, and then we're going to do a cosine function, that b value, and then x minus a shift plus a k. So this one we're actually going to have a shift, and depending on how you shift the graph, you might get a slightly different equation. Your answers might be slightly different from mine, but it's going to be relatively in the same ballpark, and as long as I can see your math, you're fine. So to find the amplitude, I'm going to take my highest and lowest and find the difference between them and split that in half. So I'm taking the distance from lowest to highest, find that distance, and then cut that distance in half. So 27 minus negative 16, and cut that in half, and you get 21.5. So that's going to be the distance from the highest to the middle. The k value, that mean line, is going to be how high up it got shifted. So we're going to talk about taking those distances, adding them together, and then finding halfway between that. So 27 plus negative 16 divided by 2, and we get 5.5. And then the period here, well, it's going to cycle through in 365 days. We're not getting into, well, what about leap year, all that kind of stuff. 365 days. So for the b value, we're going to take that 2 pi and divide it by 365. And then we're also going to have to kind of move this graph because it's not at the highest or the lowest on January 1st. So I'm going to say, well, it gets shifted to the right to January 10th. So we're going to move it to the right by 10 days. So that's my h value. So I'm going to write my actual equation up here. Also, it's at the lowest point where we've shifted this. So for a cosine function, if it's at its lowest point where it's starting, then we need to include a negative. So not a, but, and I'm going to do the temperature on a specific day is going to be negative my amplitude, 21.5, cosine, and then that b value of 2 pi over 365, my input value minus 10 because we shifted it to the right 10, and then plus that 5.5 for moving it up. So this is our function. Part B says to graph this. So here's 365 days. So I'm going to put January 1st here, January 1st here. So somewhere in there is going to be June. And then that's all I'm really going to put for my time. So time is in days. And then on the other axis, it's going to be the temperature in degrees Celsius. So the lowest temperature that it's going to get to is -16, and the highest is 27. So I don't know, 10, 20, 30, -10, -20. There we go. So my function, slightly over, is going to be at -16. July is going to be at the highest, and then it's just going to go like this. So something like that. That's part B. I'm not going to put a box around it. C says, what is the average temperature expected for October 4th? So remember, our function is in terms of days, and it's talking about days kind of after that, January 1st. So I need to figure out what day October 4th is in the year. So I'm going to take, well, so October 4th. January has 31 days. February is 28. January, February, March, April, May, June, July, August, September, and then we hit October, but I don't want all of October, I just want that those 4 days. And when you add that all up, you should get 277. So that's 277th day of the year. So plug that into your function. And put my marker down. So we've got -21.5 cosine. A lot going on, so I'm going to put a parenthesis or a fraction there. 2 pi divided by 365. Go out of the fraction, open up a parenthesis. Now I want this 277 minus 10. Close parenthesis, close the parenthesis for the whole thing, and add 5.5 to it. And I get close to 8 degrees Celsius, or 7.99. If you had shifted maybe your graph, you talked about the starting point up here, and so you'd have to figure out what day of the year July 28th is and kind of adjust that way. Your answer on this part might be slightly different, and that's okay. Okay, and then part D, the average temperature is higher than 23 degrees for how many days? So again, we're going back to 23, it's right here. So I want how many days is it above that temperature? Well, I need to find where is it at that temperature. Again, you can use your graph. I'm going to show you how to do this kind of by hand. So part D, I'm going to say 23 is equal to my function, -21.5 cosine craziness So I'm going to subtract this 5.5, and then I'm going to divide by the 21, negative 21.5. So I'm going to end up with negative 17.5 over 21.5. And that's going to equal the cosine of the crazy. So when I do cosine inverse, that's the part that's going to be a little weird. Let me write that out. Equals 2 pi over 365 times d minus 10. So let's kind of sidestep and look at this cosine inverse right here. That does show up, awesome. So if I'm looking at that, cosine again is negative in the second and third quadrants. So some angle right there and some angle right here. So to find that, I'm going to use my calculator and see what it gives me. So cosine inverse of, what was it, negative 17.5 divided by 21.5. So 2.52. That's this angle right here. And it makes sense that it's not all the way to pi, which is 3.14. And that distance right there is going to be the same as this distance right here. So I'm going to pretend like I went a full rotation of my circle. And I'm going to backtrack this same distance, 2.52. And we get 3.76. So I need to replace this cosine with each of those values. So this cosine inverse, so 2.52, I grabbed the wrong marker, whatever, is going to equal this. So I could distribute this. I don't really feel like doing that because that's going to make it a little bit more complicated than what I want. So I'm going to multiply by the reciprocal. And that's going to give me that d minus 10, so I'm going to have to add 10 to that to get my value. And then I'll plug that into the calculator in a minute. Same thing is going to happen with that second angle. I'm going to multiply by the reciprocal. And then add 10 to account for this. So we get, turn the calculator on. There's a negative in front of there that I didn't want. So I get 365 divided by 2 pi. Now, if you're not visualizing the fraction like this, you have to make sure you're putting the denominator in parentheses. Then multiply that by 2.52, and then add 10. So 156.39. Since we're talking about days, I'm just going to say 156. And then the second one, you can just arrow up and highlight, go over and just replace that number. but I'm going to show you if I am not using the visual fraction. So 365 divided by, I have to put the denominator in parentheses or it's going to read this incorrectly, times 3.76 plus 10. And so that is my 228, so 228 days. Now if I go back to my graph, I found 228 and 156. I don't necessarily care what those days correspond to in the calendar. What I do care about is how long is that happening? Well, take my 228 minus my 156. And I get 72 days. The baby might be waking up. So it's going to spend 72 days above 23 degrees Celsius. That is the craziness of that problem. Can't even get it into the thing. Yep, baby's awake. Email me with questions. That is the last example for this lesson.